This is Dr. Papia from School of Engineering, Republic Polytechnic. For this part of my presentation, today I will be talking about Dilution Air Processing Unit, in short DAPU. I'd like to start with a problem statement. As we transit to endemic COVID-19, there is a growing potential for our existing ventilation technologies to be redesigned and modified or developed in such a way as for better and effective infection control. Uh, Improvement in the indoor air quality conditions, of course, is the uttermost goal, but we'd like to look for more innovative approaches to do that without the significant increase in the energy consumption as well. In the School of Engineering, we have developed this technology, Dilution Air Processing Unit, in short DAPU, which is able to reduce the extent of the airborne particles exposure to the indoor occupants. The novelties of this technology are higher airborne particle reduction as we combine the two methods. One is the 100% pressure change or the dilution ventilation technique, and the other one is the more air cleaning strategies like the bio-antibody filtration technique. So combining these two approaches, we have improved energy efficiency and the lower operating cost and also with the help of the modular and portable design feature, there is an ease of implementation as well. So this is how the DAPU system will look like. It will be usually installed outside the isolation test chamber, and it is able to change these air within the isolation test chamber in every 2 to 3 minutes with the fresh outdoor air. The internal configuration, as you can see, consists of multiple process integration consisting of pre-cooling, dehumidifying, and sensible cooling options. The bio-antibody filtration technique is usually a masking technique, as we mask the indoor air opening, especially the return and the supply air openings within the isolation chamber. The performance-wise, DAPU has shown good potential as the HVAC energy usage, if we compare daily basis, the watt-hour consumption. The different mode of operation of the DAPU has shown good potential in terms of the energy consumption. For example, if you configure the DAPU system in a traditional mode, which is mostly similar to the residential air conditioning system, without any ventilation, of course, the energy consumption is much lower. But the moment we start to add on the fresh air ventilation, the energy consumption significantly increases. Now, if we look into the last two columns here, DAPU has better energy savings compared to the traditional method of doing the similar 100% fresh air exchange. For the particle efficiency, DAPU has shown good potential as well. As you can see that the cumulative particle density for the traditionally used no fresh air option using the regular filter, the particle density is the reference point. So if we add on the biofiltration technique for this zero ventilation case, we can already see 45% reduction in the PM 1.0 concentration level. Then if we combine the biofiltration technique with the 100% fresh air change, this is further reduced by nearly 70%. So overall, DAPU has shown performance as indicated here. The integrated airborne exposure for the PM 1.0 particles is nearly 65%, energy savings 25%, and simple payback for the high usage area can be less than 1 year. The commercial viability will be much higher for those very high risk areas like the healthcare facilities and the recovery centers. As for regular high risk and the moderate risk areas, the implementation is still viable, but the viability is affected due to the building owner's choice of implementation and also the retrofitting options. So that is all for my presentation today for the dilution air processing unit. For any further information, you can approach to this email address stated here. Thank you very much for your attention.